You're listening to The Skeptic's Guide to the Universe, your escape to reality.
Hello and welcome to The Skeptic's Guide to the Universe. Today is May 16th, 2025, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Kara Santamaria.
Howdy.
Jay Novella.
Hey, guys.
And Evan Bernstein.
Good afternoon, everyone.
Yeah, so I think I'll be using this particular episode in the middle of July while I'm traveling, so that's why we're recording a couple of months before it's actually going to air. So who knows what crazy stuff has happened in the next
That's
2 months as we record this, previous 2 months as you listen to this. There could be something going on like we're totally clueless about.
Right. We hope you're not in a bunker right now.
Yeah, this could be a time This is our
enjoy.
time capsule episode. It could be.
Yeah, and I was just interviewed by a Finnish magazine. They wanted,
like a place where they,
no,
prepare
from
people
Finland.
for clothing and accessories?
No.
That kind of finishing?
They wanted to talk to me about RFK Jr.
Oh, that.
All the ways in which he is absolutely destroying healthcare in the United States.
So it was
so
like a
depressing.
5-hour interview.
Yeah.
No, I had to do it quickly because I'm prepping for recording this. But I hit everything. I knew it was like, don't even bother asking questions. Here's what you wind up. Blah, 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 blah. No, but she had the correct questions. But she had a couple of, reportery ones. Like, he's softening his rhetoric. Do you think he's modern? No, stop. Not at all. No. This is all BS. But it is, so I was reviewing everything just to have quotes and stuff handy. It's just amazing how it's so much worse than any of us thought it was going to be. Even those of us who thought it was going to be an apocalypse, it's even worse.
Yep.
Just to give a very quick review, he's replacing people at the CDC and the FDA with anti-vaxxer cranks, right? The CDC is no longer going to be releasing its morbidity and mortality date reports, right? So we won't be tracking infections, They are no longer going to be essentially promoting vaccines. It's all personal choice now.
They're also limiting access to vaccine. They're rolling back a new vaccine, the new one that's finally been kind of approved. They're rolling back access. They're saying, you can only take it if you're over 65, back to the original parameters.
Mm-hmm. So one of the big things, so this is something that I think it requires a little bit of explanation, so I'll just say it very quickly. He is recommending that for all new vaccines, there are placebo-controlled trials. So that sounds superficially good, right? You're like, well, that's good, right? We should be doing placebo-controlled trials. But here's the thing. So right now, first of all, the big anti-vaxxer talking point is that we don't do placebo-controlled trials for new vaccines, and that's wrong. That's a lie. We absolutely do placebo-controlled trials for new vaccines. But there are two types of vaccines for which we don't do placebo-controlled trials. One are vaccines where they're just updating the vaccine. So there's already an approved, safe and effective vaccine, and the pharmaceutical company's we want to tweak the formula, right? So they're updating it. The second kind are ones where they're making a strain update, right? So it's with the flu vaccine, we're now going to make targeted against the new strain. It's the same vaccine. They're just making it with a new strain.
Is the idea here, Steve, that it would actually be unethical to give a bunch of people a vaccine that doesn't work?
100%.
Yeah, that's 100%. What I figured. We know the flu vaccine works. We can't give people a fake vaccine.
You can't give people a placebo. Yeah, then the broader, to state the ethical principle more broadly, you cannot withhold proven therapies from people in order to get them into a clinical trial.
Exactly.
Right? You can't say, we're going to randomize you to the arm that doesn't get standard of care, or doesn't get proven treatments. We're going to withhold effective treatments from you just to see how bad things get.
Yeah, we can only do that when we don't know if the treatment is proven yet.
Right, but if you have a proven vaccine and you're updating it, then what we do is we compare it to the existing vaccine. That's the baseline. Right. We know it works. We know it's safe. We test the new one against the baseline and to make sure that no new side effects crop up or that it's at least effective or hopefully more effective or whatever, right?
Yeah, because what happens if the ones who were to get the placebo, the hundreds of people who were to get the placebo were exposed to the flu because it's flu season, got sick and died?
Yeah, exactly. So that means no IRB, no respectable, legitimate IRB would approve that study, which means it will never get done. That's an institutional review board. They're the people who review the clinical trial and make sure everything's on the up and up, including ethical. So probably the studies just won't get done. So it's just a backdoor way of shutting down vaccines, because all vaccines are updated, at some point in time, and some need to be updated to the latest strain, right? The flu vaccine, if you weren't updating it every year to the strain, it'd be useless practically. But so couching it as we're going to do placebo-controlled trials equals we're going to shut down any new vaccines.
Yep.
Any vaccines updates or strain updates by making an unethical recommendation.
Wait, so isn't the flu vaccine this season then the people getting really sick going to explode?
Yeah, of course.
Of course.
So all right, well then.
The other thing
wonderful.
For the strain updates. Even if we did do the study, they did approve it, it would delay it by 6 months. The flu season's over.
Right.
So you can't track the strain.
Yeah, what do you think would happen? Like, we had X people, the effectiveness of the strain of the flu vaccine last year was this, and now it's far, far worse, and we had, 30,000 more people die.
Well, they're not going to report them. They're not going to, because the CDC's shutting down their reporting.
There you go.
Yep.
Ooh.
So, but is there no other way to get the information, Steve?
Well, we'll see.
Well, that's the difference between this happening in 1938 and this happening in 2025. The hope, right? The hope is that there will be enough people with independent capabilities, but it is hard to do things like that on a national level. I think some universities are going to try. Some different states are going to, they're going to try to take those numbers. Exactly.
Probably.
But, or we're going to start seeing states going around these federal guidelines to protect their people. And then we're going to see bigger differences between health outcomes amongst the states, which we already see. That's just going to grow. I mean, talk about, Steve, did you talk about the fluoride stuff, like the fluoride supplements?
Didn't even get there. This is more about the vaccine.
Wow. Yeah, I mean, it's amazing.
I know, it's terrible. And so the thing is, so many things are happening at once. Again, it's interesting. This is 2 months later. You'll know more than I do about what's already happened. But they're attacking the reporting of data. They're attacking the rollout, the updating, the study of vaccines. Then they're also attacking the universities who could potentially keep them honest about it. Mm-hmm. And they're also trying to prevent states from bypassing their terrible federal regulations. Right? They are fighting on every front. So anything you say, well, this could happen, they're actually trying to prevent that from happening too.
And it's one thing to be incompetent. It's one thing to be, I guess I would say, weaponized ignorant, like intentionally ignorant. Sure. It's another thing to say our weaponized ignorance and incompetence is going to be the rule of law, and we are actually going to ensure death. Like, not just, oopsie, some people died. We're going to make sure that we ensure that people die.
There's a body count with this.
Yeah,
100%. But it's also I wouldn't even say the rule of law. It's because they're substituting the rule of law with the rule of a person.
Oh, you're so right.
This is the rule of Trump. That's what we are under. It's none of it is really.
Well, and you sort of left out the Fifth Estate, and that's what, I mean, I know that this is not timely, but as of last night when we're recording this, or 2 nights ago, that's what John Oliver's most recent episode was all about, the media, and how we're starting to see the media kowtowing to pressure.
They're backing down, too.
They're backing down. They're censoring themselves. They're not pushing back, and that's so frightening.
So what's left?
Exactly.
Science podcast.
Yeah. To do this thing.
So we're like the geeky little nephew that saves the Enterprise. Is that where we are? Third line, the last line of defense.
I think of us like that little boy that spoke like an adult in Star Trek: The Original Series that was drinking Tranya.
Oh, that always creeped me out.
Tranya.
Sure.
Carol,
that's
just roll with
you guys. You have no idea.
Chances of you knowing that are 0.
Exactly.
That the rest of us are like, yeah, absolutely.
Oh, sure. That makes total sense. Perfectly cromulent.
All right, Bob, start us off with a quickie.
Woo. Oh, boy. Thank you, Steve. This is your quickie with Bob. New details have been recently revealed about one of the hottest exoplanets ever discovered, Kelt 9b. Astronomer John Allers describes it well when he said, the weirdness factor is high with Kelt 9b. Why would he say that? Let's see. So Kelt 9b is about 670 light years away in the constellation Cygnus. It's a gas giant, and it's a behemoth. It's 1.8 times bigger than Jupiter with 2.9 times its mass. And it doesn't have a nice stately 12-year orbit around its star like our big gas giant Jupiter does. Kelt 9b has a 36-hour year. 36 hours to go around
It's
its
whipping
star.
around.
Yeah, going fast. It's so close. It's 3.2 million miles or 5 million kilometers away, which is far closer to Earth than Earth is, and it's 1/10 Mercury's orbit. 1/10. The closest planet in our solar system is like far away from this one, and its orbit brings it almost directly above its poles, right? Which is odd. When you think of a planet orbiting a star, it's orbiting like in the equatorial region, not over its poles. It happens, but it's not. I don't think it's terribly common. Okay, so as you might imagine, the planet is quite hot. It receives 44,000 times more energy than the Earth does from the sun. 44,000 times. So that makes its dayside temperature 7,800 degrees Fahrenheit, 4,300 Celsius. That is hotter than the surfaces of some stars. So yeah, this is a hot planet. Yeah, imagine. Yeah, see that star over there? This planet is hotter than the surface of that star. Now, of course, the astronomers imagine that such an incredible heating is causing the planet's atmosphere to stream away into space to a certain extent. I wonder how long that would last. All right, you can't do that forever. And the star is also weird. The star is twice our sun's size. I believe they said it's the radius, twice the radius, and 56% hotter. And it also spins 38 times faster than our sun. So what do you guys think? What would such a spin do to a star like that?
Well, it changed its shape.
Centrifuge.
Yeah, exactly, Jay. So it's like an oblate spheroid. It's flattened at the poles. Imagine you're squishing down the poles closer together in a sense, and that widens the equatorial region. Right, the Earth is an oblate spheroid, but it's not as dramatic as this one. So this has a result that I haven't heard about before. It's called gravity darkening. Never heard that term before. It's interesting. That means that the polar areas are hotter and the equator is cooler. And so if you could take the temperature at the poles and at the equator, you'd find a difference, almost 1,500 degrees between the two, 800 degrees Celsius difference, which is dramatic. I love how they describe the planet as having 4 seasons in its 36-hour year. So it's got 2 summers and 2 winters. You're going over the poles twice a year, and it's hotter. Then you're going over the equatorial area, and it's a little bit cooler. So it's got 4 seasons. Let's see. Nicole Colon, as a co-author of the paper, said it's really intriguing to think about how the star's temperature gradient impacts the planet. The varying levels of energy received from its star likely produce an extremely dynamic atmosphere. Yeah, I think this would have an amazingly dynamic atmosphere. It's also tidally locked, as you might suspect. So we got some crazy, and just imagine the interplay between the incredibly hot sun side and the farther night side, and then of course you got that strip between. What's going on there? Are there any temperatures that are even remotely pleasant? I doubt it, but who knows what's going on. All right, guys, so Google Kelt 9b to find out more fascinating details. This has been your Gravity Darkening Quickie with Bob. Back to you, Steve.
Thanks, Bob. Jay, how the Voyager's doing? I heard they're still kicking out there.
Well, this is Voyager 1. Mm-hmm. This is, guys, I have to say, this is one of the most impressive feats of spacecraft troubleshooting, engineering. Definitely nowhere near, though, the Apollo 13 air scrubber fix.
Oh, geez, right.
That was largely credited to one man who recently died.
Oh, really?
NASA engineers successfully reactivated a set of thrusters on Voyager 1 that hadn't been working since 2004, and there was a really important reason why they pulled this off. So quickly, Voyager 1 launched back in 1977, and it's currently the most distant human-made object in existence at over, anybody know how far away?
Oh, gosh.
All the far away.
Damn.
All the far away?
About 100
All the
miles.
fars, yeah. How many?
15 billion miles.
Ooh.
It's 15 billion now. Wow.
Billion.
That is
Damn.
crazy.
How many light hours is that?
It
Yeah,
left-
it's
I
like
don't
a
know.
meaningless number to me. So, where is it physically?
It left our solar system over 10 years ago.
Yeah, it's amazing.
Well,
And the
yeah.
yeah,
It left the
Bob's gonna
heliopause.
push back
Well,
on
whatever
this.
okay,
Bob.
Bob, right. We could have a side conversation for an hour about where's the rim, blah, blah, blah.
Oort
It's no
cloud.
It's still
longer...
nowhere near the Oort cloud, so yeah.
Did it leave the heliopause?
Yeah, it passed the influence of the sun,
Of the sun.
sun's influences. So it's basically in a sense it's in interstellar space. But still, there's you got the Oort cloud, which is still I think a light year away. So it's it's nowhere near that. But yeah, in a sense, yeah, it left the primary influence of our sun,
How do we know where
the heliosphere.
Because we're in communication with it.
Yeah, right.
We know what direction it's in.
The trajectory.
And we know
exactly. We
by
can
how long
calculate that.
by how long it takes to transmit to us. We know how far away it is. So in order to keep those transmissions from Voyager going, NASA has to maintain this very, very precise orientation. So its high gain antenna stays pointed at the Earth, right? If that antenna doesn't point at the Earth, we're not going to get the signals. So to do that, Voyager relies on these small thrusters that control its orientation, particularly the roll motion, which helps it stay aligned with a guide star that they're using to help the overall alignment. This is tough, and I would imagine that the farther away it gets, the more difficult that's going to be. The problem is nothing on board Voyager was built to last 47 years. So the primary roll thrusters, which are used to control these very tiny little movements that we needed to make, they stopped working in 2004 after their internal heaters failed. And apparently the heaters need to function in order for the gas that they're emitting to flow properly. NASA engineers assumed that the system was completely done, and they switched basically everything off, and they moved over to the backup thrusters. So those backups have worked really well in way past what NASA thought they would be able to do, but they gradually are now clogging due to propellant residue, which, again, they didn't think it was going to last 47 years. I don't think residue was a problem when they were building it. So Voyager 1's thrusters are powered by hydrazine, and this is a monopropellant fuel, and it's usually used in spacecraft attitude control systems, right? These little thrusters that you'll see in movies and stuff that move jockey things around. It's stored in a liquid form. It's in pressurized tanks. And my first question was like, is there enough of that stuff?
Yeah, right.
I think they need so little of it to make the adjustments that's why it's lasted so long. But there's got to be a time when they know that propellant's is gonna no longer be there. So if the thrusters failed completely, Voyager would simply just lose its ability to stay oriented with the Earth, and that would effectively just and quickly end the mission, because no more talking, no more mission. And to make this problem even worse, NASA, the only antenna that's powerful enough to send commands to the spacecraft, this is called Deep Space Station 43, DSS-43. It's in Canberra, Australia.
I thought you were going to say Deep Space Nine. I was going to.
Yeah, if I read Deep Space Nine in my head the first time I read it, I'm like, Deep Space Station 43. It's like, no, Deep Space Nine. Just call it Deep Space Nine and everyone can go home.
That's right. We're conditioned that way.
So the Deep Space Station 43 is scheduled to go offline from May 2025 through February of 26 because they're doing a major overhaul of it. And this means that the team had this very narrow window of time left when that dish is functioning to attempt to fix. Or, with the article that I first read, it said, it was a risk being unable to send commands for 9 months. No, what would happen is without the thrusters working properly, it could just veer off its angle to us and no longer be able to right itself, which means the mission would have died. So I think the few articles that I read and everything were underplaying the severity of it. Like, it would end the mission, apparently. So they had to get the fix in. They had to come up with the fix. They had to send it. And it takes 2 days to send and receive, right? It's 23 hours each way. So this was a nail biter because when that dish went out of service temporarily, there was just nothing that could be done. And over 9 months, that could have been the end. So engineers at NASA's Jet Propulsion Laboratory, they went into full-on think outside the box mode. Of course, lots of people were proposing different things, and they were scrambling. They had to really. This was a real close call. One team member proposed this novel idea, which is, what if the heater system isn't actually broken mechanically, but it was just disabled by a circuit being off or something like that, like some other downline thing that could affect it and have the same exact effect, right? The switch could be in the wrong position somehow. And if they could reset it or flip it back, essentially resetting the power pathway, they might be able to restore the heaters, which would then allow them to bring these primary roll thrusters back online, right? And that idea, it's risk. It was very risky, and this was a big thing that NASA had to figure out: is it worth the risk? Because first, they send the commands to restart these dormant thrusters, Then they have to carefully realign the spacecraft, again, like I said, to point the star tracker as its guide with super high precision. And if the roll thrusters came alive too soon, right, as the heaters are heating up, and if those thrusters, were able to function, and, this machine is 47 years old. Before the heaters could completely warm the thrusters, the thrusters could very likely misfire or even explode. And if they exploded, goodbye. That was it. It was an unrecoverable situation. So the timing on everything of all these different nuances in the system were wicked important to go specifically as they spec'd it out. So they sent the command on March 20th, 2025. Since Voyager is so far away, like I said, it took 23 hours to send it out, and then it was executed. Then it took 23 hours for it to send a message back. So they had to wait almost 2 days to find out if they bricked the Voyager or fixed it, right? And that, again, that the news could have easily just said Voyager 1 is toast. So when telemetry finally came back on, it showed the heater temperatures rising dramatically, which is a clear sign that the plan worked, and the thrusters came back online and they work.
Amazing.
So that one scientist at JPL basically came up with the idea that maybe it's not broken, which is so counterintuitive, right? Because the thing's been broken for, 11, 12 years,
But I like that, though, because that's always a good plan. Let's assume this is doable, or let's assume it's fixable. What could we do? Yeah. I often do that in medicine, and I tell this to my students, all right, what could this be that's treatable? Just think about it from that perspective. Don't worry about how likely it is. Just, is there anything this could be that is treatable? And then let's make sure it's not that, or let's treat it empirically, right? Because what have you? If you assume it's untreatable, that doesn't lead you to anything useful,
right?
Even if it turns out to be the correct answer, you haven't lost anything, right? Because if it's untreatable, it's untreatable. It's the same kind of thing. Let's assume it's fixable.
Yeah. Steve, he was a lone wolf.
Good for him.
Tom Barber, who was the mission lead at JPL, he said, and I'm quoting, "These thrusters were considered dead, and it turned out one of our engineers had an insight that maybe it was fixable." Right? That was all it took. Hey, guys, maybe this thing is set to evil,
Here's your problem.
Yeah, someone set the Voyager to evil.
My final statement, this sentence I'm about to read to you that I finally crafted, is meant to have massive subtext. Let's see if you guys can pick up on it.
Okay, ready.
This kind of success isn't just about keeping the 47-year-old spacecraft running. It's a perfect example of how a highly trained scientist, using creativity and a nuanced understanding, could carefully engineer a seemingly, 1 out of a million fix, even when you're dealing with a 1-ton robot, racing through space at 35,000 miles per hour. That's 15 billion miles away. Science kicks ass and can do things that we never thought possible. Subtext, RFK is a jackass.
All right, thanks, brother. All right, Kara.
Yes.
I suspect we're going to have some lively discussion.
I think so, and maybe some emails. Maybe.
Okay.
Tell us about space tourism.
So I came across an article that was written by Betsy Pudliner. I looked them up on their university website at University of Wisconsin Stout, and they are a professor of hospitality and technology innovation. Kind of their little bio is, with more than 30 years of experience in the tourism industry, Dr. Pudliner has cultivated a deep understanding of the field shaped by travel, blah, 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 blah. Okay, so this is a researcher of tourism, which is fascinating. And they wrote an article in The Conversation, Space Tourism's Growth Blurs the Line Between Scientific and Symbolic Achievement. A tourism scholar explains how. So if we all remember, April 14th of this year, there was a very media-friendly, media-focused launch by Blue Origin. So Aisha Bowe, Amanda Nguyen, Gail King, Katy Perry, Carrie Ann Flynn, and Lauren Sanchez. What do these 6 human beings have in common, other than the fact that they flew on a Blue Origin?
Their cities.
They're celebrity or, figures.
I don't think all of them were
culture.
Celebrities.
They're civilians.
They're civilians. What else?
They're
Something
women.
really obvious. What?
They're women.
They're women. right? So what were the headlines that we saw?
That, all female crew
Right.
that went into space.
Historic moment for women in space. We know all female astronauts dominate the skies, or, whatever. And the question that, like, I would pose to you, that Betsy posed to the audience or to the reader, that I think obviously the heart of this conversation is, were they astronauts or were they space tourists? And what does that even mean? So if we were to take a poll, what do you all think? What do you vote? Astronaut or space tourist?
Well, in the past, they used to reserve the term astronaut for having achieved a certain altitude. I think that in some technical sense, you became an astronaut, but I'm not sure if they refined it since then.
But that's a completely separate, indication, right? So you can set one threshold for did they get high enough to be in quote unquote space. But let's say they were in space, and that we put that issue aside.
Yeah.
What were they? Right. That's the question.
That is the question.
And
right?
so it's a continuum.
When you say in the past an astronaut has a certain, but there are other definitions of an astronaut.
Yeah. It's a continuum, right? So clearly if you're a pilot, right, if you're operating a spaceship,
If you're controlling,
you're an
machine.
If you're the
astronaut.
crew, if you're part of the crew.
Yeah.
Yeah, what if you're
Right.
crew?
That's
What
the
if you're a
standard
payload
response.
specialist?
Yeah,
Yeah, we're all flying airplanes, but we're not the pilots.
So payload specialist. So but if you're working in space, like if you're like going on an EVA to do work that is occurring in space that can only be done in 0G or
Science
whatever.
research, yeah.
Yeah, that's also I think an astronaut. But that's right. It's a continuum. But what if what you're doing is not specific to space? Like let's say you have nothing to do with flying the ship. You go up to the space station and you fix the toilet and you come back down. You're a plumber. You're a plumber in space. Does that make you an
space
astronaut?
I might consider that a space. I might consider that an astronaut, but I will say it also has a lot more to do with not what you're doing once you're there, but everything you did to prepare to get there.
Well, that's another thing. Yeah. How much
I like
training
that.
did it take?
Yeah.
How much
I
training?
like that angle.
And how
'Cause I
we-
was going to say something like, if you're doing work, that would lean me towards thinking that you're more of an astronaut than not.
All right, what if you're a journalist?
But prepping.
Interesting. Yeah.
They're just there to experience and document your experience.
Yeah, we're like, let's think about wartime, right?
I'd
we're
say they
we're
are
embedded
not
journalists,
right.
soldiers.
Well, right, but there are civilian journalists also embedded with soldiers. They're not soldiers.
Yeah.
So there's different types.
Yeah.
There's different types. And that civilian versus expert or civilian versus professional distinction is an important one here, right?
Yeah,
because,
I think so.
And I noticed that Betsy uses that throughout their writing. They say things like, as commercial space travel becomes more accessible to civilians, more people are joining space flights, not as scientists or mission specialists, but as invited guests or paying participants.
Yeah.
That line between astronaut and space tourist is becoming increasingly blurred.
What if you have to train to like wear the spacesuit?
Just to wear the suit?
Yeah.
Yeah, that's interesting. So basically, they did say something, kind of interesting in their writing. Were these passengers astronauts? Not in the traditional sense. They weren't selected through NASA's rigorous training protocols, nor were they conducting research or exploration in orbit. Instead, they belong, and they claim, to a new category, space tourists. These are participants in a crafted, symbolic journey that reflects how commercial spaceflight is redefining what it means to go to space. And actually, they point to, and I didn't know this, origins of space tourism going all the way back to 1986 when the Mir was launched, because the Mir was the first kind of thing, they call it the first orbital platform, to host non-professional astronauts. So in the 90s, the 2000s, Mir and then the ISS did welcome a handful of privately funded civilian guests. And the most famous one, I guess, was in 2001. There was a businessman from the U.S. named Dennis Tito, and he's often cited as the first space tourist, all the way back in 2001.
Did they call him an astronaut?
Wow, that's a
No, they
surprise.
called him a space tourist.
Right.
And so now we're starting to see this market, right? We're seeing Virgin Galactic, we're seeing Blue Origin, we're seeing SpaceX having these kinds of conversations. And I highlighted a quote directly from the article that I think was very, I don't know, like they said it way better than I could summarize, and it's pretty short. The Blue Origin flight was not a scientific mission, but rather was framed as a symbolic event. In tourism, companies, marketers, and media outlets often create these performances to maximize their visibility. SpaceX has taken a similar approach with its Inspiration 4 mission, turning a private orbital flight into a global media event complete with a Netflix documentary and emotional storytelling. The Blue Origin flight sold a feeling of progress while blending the roles between astronaut and guest. For Blue Origin, the symbolic value is significant. By launching the first all-female crew into suborbital space, the company was able to claim a historic milestone, one that aligned them with inclusion, but without the cost, complexity, or risk associated with a scientific mission. In doing so, they generated enormous media attention. Because you can imagine if this was a haphazard crew, or just a crew, not just, but a crew of a bunch of different people in, mixed gendered crew, it would not have gotten the media attention that it got. Mm-hmm. But this author points to the fact that although this seemed like this big victory, it was really symbolic about visibility, about inclusion, about celebration. It's not the first time women have been in space. There have been 61 women astronaut candidates. Many of them have flown. Sally Ride, Mae Jemison, Christina Koch, and Jessica Meir. But they trained as astronauts. They contributed to science, engineering, and long duration mission research. There have been historic achievements. And so the question is, when we see all the media attention around these women who flew up and came down and then had all of this press around them, is that something that we should celebrate, and should it bolster, women in science, women in space, this is amazing? Or, and maybe I should say or, does it actually minimize the accomplishments of the women who came before them and who will come after them, who are doing astronaut work?
Yeah, so like many things that we talk about, this is primarily an issue of categorization, which is ultimately arbitrary and context dependent. So, back in the day, everyone going into space was an astronaut. There was no question about their status because you had to be trained. You were doing something. There was no tourists, no dead weight, nothing except for pilots and mission specialists, basically people who were absolutely astronauts. Now, the categories of people going into space is broadening, and we could start to split them out into different subcategories. There's space travelers, people who go to space. Some of them are astronauts, meaning they're professional. Their profession is going into space in some way or working in space, all the way to tourists who do absolutely nothing. But in between, there's going to be a continuum of people who are doing some job in space,
the in between,
or doing something. Again, just your job is to be a tourist and write about it. If you take a picture and now you're a space photographer, does that also make you an quote unquote astronaut? There's no right or wrong answer here. It's, and we have to think, as you say, about the meaning of these categories and how that is communicated to the public, and how that affects the space program and space tourism, and how the public thinks about it and about what it means to us as a society, culturally, everything.
And that's the framing that the author really takes. They talk a lot about the history of tourism and tourism theories, which I didn't even know there was a whole area of scholarship around this, but that tourism is really an evolution over time. So, and they even have a little kind of graphic of starting with exploration into development, consolidation, stagnation, then sometimes rejuvenation or decline, where they show that the earliest tourists very often were and are hand-selected that are either inordinately wealthy or it's seen as some sort of rite of passage. And we think about early exploration in the same way. There have always been tourists who are along for the ride because they could pay their way onto the ship, because they could pay their way along. And they may have contributed to history and science as well, simply by virtue of being present when something miraculous was happening. But then over time, it becomes more democratized. So they talk about the Grand Tour of Europe, which was a rite of passage from, I just pulled the article, 1600 on, that eventually it became a pretty accessible thing to do. But early on, you needed kind of a lot of money, you needed a lot of prestige. How do you get that ticket? How do you get that spot? And then eventually modern travel sort of mimicked that. And so the idea here is that, with space tourism right now, we're in the exploration stage. It's expensive. It's exclusive. It's invite only. It's available only to a few. The infrastructure is limited. Companies are experimenting with what it looks like. It's not mass tourism yet, but maybe it will be. And so how we talk about it right now, how the media shapes these narratives is going to have a big impact for the categories that we use in the future. And I think as much as it's, a categorization problem, and as much as we often talk on the show about the idea of constructivism and we put a label on something and that label is arbitrary, that doesn't mean it doesn't instill deep meaning, right? Mm-hmm. It can be both arbitrary and deeply meaningful. Sure. And so that's something we definitely have to think about, because the narratives, the storytelling is actually all of it right now. It's less about the thing itself and more about how we spin the thing. That's going to affect what we think about it in the future and what the future of space exploration actually looks like from both the tourist and, professional perspective. It's a fascinating question, though.
Yeah,
and it's one that's near and dear to my heart because I have friends. I know people who have been to space, both as astronauts, in the very traditional sense, and then as sort of what I would consider tourists, but who might have used or had the label put on them as astronaut. And I've always grappled with the feeling that comes up for me when that label is used. So, and I think we all kind of need to do that.
Mm-hmm. Yeah. It's like, what's the difference? Where's the line between an explorer and a tourist? Right?
For sure.
If it's the first time you're going someplace, or it's exotic to you, at some point does that make you a little bit of an explorer, or maybe you're just an adventurer versus you're just a tourist because there are people already there. Mm-hmm. But was Columbus a tourist because there were already people in the Americas? Anyway, it's
complicated.
It's complicated.
Yeah, it's complicated.
That doesn't mean you can't, as you say, you can still make meaningful and useful definitions, even though you recognize that this is just imposing patterns on reality, which is infinitely nuanced.
And I think the part that kind of bums me out too is that in taking on a label that maybe doesn't feel earned or genuine, it minimizes the label that actually doesn't need to feel minimized. Does that make sense? Like being a space tourist, being the first space tourist or an early space tourist is actually really cool. And so owning that and celebrating it and being like, I'm helping pave the way for many people just like you to eventually do what I do. Like, what a great thing to celebrate. But in being like, I'm an astronaut, then there's all this like, really, are you an astronaut? And now all of a sudden we go, no, you're just a space tourist. And I don't like that.
Yeah, but you could use a term like you're a spacefarer.
Right. Or you can just celebrate the terminology. Yeah.
So it's not a tourist definitely has a minimization feel to it.
Oh, yeah, absolutely.
But astronaut is obviously the maximally, sexy terminology. But I agree, there should be something in the middle. Like, it's an accomplishment. You put your ass in that seat and you got shot into near orbit, whatever. Yeah, and you know what I mean? That's something.
It's not trivial.
It's not trivial.
It's a huge accomplishment. But there is something kind of yucky that happens when somebody who makes a massive accomplishment embellishes and uses terminology even beyond. It's like, can't it be a massive accomplishment on its own? Because the second you go, no, but it's this thing, everybody goes, no, it's not. It's just that thing. And the is the problem. Because it's still very cool in and of itself.
Don't embellish, but don't minimize.
Yeah.
But I mean, it might mean that we're always tinkering with the terminology to try to capture the right connotation, the right nuance. All right, let's move on. So, more bad news about the climate.
Oh, God.
There's always going to be bad news about the climate.
Yep.
One of the big issues with climate change, with the warming average global temperatures, is melting ice. That has a problem for numerous reasons, but one of the big reasons, depending on where the ice is coming from, is that melting ice can raise sea levels. Do you guys know, like Jay, what do you think is the two main reasons that sea levels rise due to a warming climate?
I think the obvious one is, like you're saying, why does it rise?
Yeah, why do sea levels rise?
Melting Arctic ice, releases of poisonous gas. That last one was a joke. I mean, what else can cause it other than more water in the ocean? Wait, does the ocean take up more space when it's warm?
Yeah, it's expanding because of the heat. Yeah.
So thermal expansion. And actually, until very recently, thermal expansion was the number one reason for sea level rise due to
But now we're losing land ice.
Yeah, so it's ice sheets.
Yeah, it's not the sea ice, it's the land ice.
Exactly,
melting.
So it's the ice sheets that are on land. So basically it's the Greenland ice sheet, the Western Antarctic ice sheet, and the Eastern Antarctic ice sheet are the three main ice sheets. There's also mountain ice and glaciers. Any ice that's on land that ultimately ends up in the water can raise sea levels.
Yeah, because ice that's already floating in the water doesn't change it.
Yeah, we're actually just getting to the point where melting ice is having a bigger impact on sea level rise than thermal expansion. But the question is, how much sea level rise are we going to get at any particular level of warming. That obviously affects the recommendations for where, like, how much do we really need to limit warming to. But that's a complicated question because it's not only a matter of the peak temperature, it's also how long we stay there. If you get the temperature get back down fairly quickly, it doesn't have as much of an impact, right? So the Paris Accord and the recommendations of the IPCC have stated that we want to keep warming below 1.5 degrees Celsius above pre-industrial levels, right? And because, based upon the science at the time, the irreversible or catastrophic ice sheet melting is likely to occur somewhere between 1.5 and 2.0 degrees Celsius warming above pre-industrial levels. So if you stay below 1.5, we're probably okay. But of course, this data, that conclusion is based upon modeling from multiple independent lines of evidence, and the data is changing, and so those numbers can change. By the way, do you guys know where we are right now? How much warming have we had above pre-industrial levels? No, in terms of degrees Celsius.
Oh, the degree?
So 1.5, right, is the Paris Climate Agreement and the IPCC recommendation.
Well, we've gone
just
past
under
that,
2.5?
right?
Just under 2?
1.9?
No. You guys we're 1.2. We're
We're
not past
there yet.
1.5.
Oh, it's so hard because we're always dealing with projections.
Yeah.
Yeah.
So,
And not-
this is what you're confusing is that we have temporarily crossed the 1.5 C, but the average, like for the year, has not crossed 1.5. We had like a heat wave where like, we're actually, for this week or this month, we're at 1.5, but not for the year. We're at 1.2. So we're above 1, but we're not quite at 1.5. We're getting pretty close now. But we're getting pretty close to 1.5, and we're going to exceed 1.5. There's at this point, there's no way we're going to keep it below 1.5. The question is, where's it going to peak and for how long?
Yeah.
And so we want to keep it as low as the peak temperature as low as possible, and we want to have it bend that curve back down as quickly as possible. And that's all about how much CO2 we put into the atmosphere. Right, that's basically what it comes down to. I mean, methane and other greenhouse gases play a role as well. Their effects are bigger but shorter term. But in terms of like over the next 100 years, 200 years, CO2 is the main forcer or driver. All right. So the new study looks at multiple lines of evidence, including historical data, like in the past when it's been warmer. How much melting has it been, or what were the sea levels like when the temperature was 1.5 C, warmer than it is than above pre-industrial levels, for example. And they concluded that in order to avoid significant sea ice melt, we need to keep global warming below 1.0 degrees Celsius. So we're already past.
Okay.
We're already past that point, and maybe even lower. They say, but at least, but 1.0 is probably closer to the number that we really need to be shooting for. Again, it doesn't mean it's too late. Don't do anything, because again, it's all about time as well. So we still need to bend that curve back down as quickly as possible. So we're at 1.2. If we can start to reverse these trends quickly, we could avoid the worst of it. And again, when we talk about these glacier melts and sea level rise, we're talking about over the next 200 years, right? A lot of these projections are to like 2300, like 2200, 2300. So
Star Trek time.
Yeah. But we have to think about what the sea level is going to be in 100 or 200 years because of something called hysteresis. You guys know, this is my word of the week. You guys know what hysteresis is?
I have heard of that word, yes.
So hysteresis is when there is a delay between a physical cause and a physical effect. So in this case, we're talking about the delay from the temperature rise to the sea level rise resulting from ice melt, which could be decades or even 100 years or 200 years. So
it's about inevitability, right? You're talking,
So we're trying to prevent the worst of the climate, of the effects of climate change, even though they won't. I mean, they could still be very bad at 2100, like by the end of this century, but they may not peak until 2200 or 2300. But by then, like, it's too late. Again, hysteresis works both ways, right? Then anything we do to mitigate or to try to reverse that trend will take a long time to kick in. It actually takes longer. Wow. It takes longer on the way down than the way up because the hysteresis is asymmetrical, meaning that it takes tens of years, right, for the ice to melt, or tens or hundreds of years, but it takes hundreds or thousands of years for the ice to build back up again, right? So it's like an order of magnitude off. So like, yeah.
Unless we artificially somehow with technology and accelerate that.
Yeah, but there's also it's not just hysteresis, is it? Because hysteresis is the delay, but we're also dealing with the negative, like, runaway feedback.
Well, that's a different issue.
Things.
You're right. That's the tipping point effect. Do other effects kick in that then make us jump to some other new stability?
Equilibrium.
Yeah, new equilibrium. That's like, our equilibrium now is 2.0 above pre-industrial levels, and that's where we are. Right? You might if you hit 1.5, you're going to hit 2.5. Right? If you hit 2.5, you're going to hit 3.5. And if you hit 3.5, you're going to hit 4.5. Yeah, so it's exactly, it's the tipping point, like a domino effect. So, and that's all. That's there's a lot of unknowns there because, again, we don't know exactly where those tipping points are. So it's all about the precautionary principle, like a actually rational, reasonable outcome of the precautionary principle, where we're saying, well, we're trying to avoid these possible tipping points because if it turns out that we pass them, there's nothing we could do about it at that point. We're kind of committed. That's the idea. Like, now you're committed to this much warming. You're committed to this much ice melt. And we're committed to meters of sea level rise. Yeah. So if all of the ice sheets, the land-bound ice sheets melted, they all melted, how much sea level rise would occur?
All of it?
Yeah.
Oh boy.
This is a wild
feet.
This is a wild guess, but 5 feet.
Yeah, many feet.
I'd say like
it's meters.
20 feet.
It's meters. So
65 meters.
Jesus.
That's 180
that's what I meant.
feet, basically.
Oh.
65 meters if it all melts.
So basically, we would only have mountains sticking out.
So that's a lot. I mean, there'd be more.
Yeah,
there would be more than. Yeah,
but that's
it wouldn't
flooding.
exactly be water world, but it would be pretty bad.
There would be no coastal areas left. It would be only the most inland of the largest land masses.
It would be unrecognizable.
Yeah.
Absolutely.
So you also think about it. All right, how many people live within 1 meter of the current sea level?
Oh gosh,
I know I do.
40% of the world's population.
No, it's not that much. It's 230 million people.
Oh.
That's only 1 meter, right?
Oh yeah,
obviously,
maybe I do.
1 meter.
It's within 1 meter, not with 65 meters, as Kara says, like everybody along every coast. But we could reach a meter by the end of the century. That's 230 million people at current population levels displaced, essentially.
Infrastructure, the whole thing.
Yeah, my elevation in LA is 305 feet. That's it.
Yeah.
I'm at 371 feet at my house.
Yeah, we're screwed.
So, but of course, it's not just like that's where the water level is. Obviously, the higher the water level is, the more surges you're going to get. There's obviously there's also tidal effects, and
storms.
There's more storms. All the other things kick in as well, and so
New York is 33 feet.
Yeah, New York
gone.
Very
8 million people
under.
just gone.
Gone. Yeah.
Wow. This is oh my god.
So basically they said 1.5 no longer is a safe level. Really, 1.0 is kind of a safe level. We're already past it, which makes it all the more urgent that we turn the ship around, that we really start to, reduce the amount of CO2 we're putting in the atmosphere and, get down to very low levels, even reversing it, right, if we could, to be taking out more than we're putting in for a while. Unfortunately, under the current administration, everything is going in the wrong direction. And even the things they're saying they're going to do, like Trump said, again, we're 2 months behind reality here, but Trump said, I want to quadruple nuclear in the United States. Like, that sounds good, but then he's gutting the Inflation Reduction Act, which was providing a lot of funding for new nuclear. So, like, what's actually happening is going to slow down the adoption of new nuclear. And, of course, he's deliberately going after anything renewable. which all, and also anything against the EV market. So it's bad times. And of course he's gutting the Environmental Protection Agency and NOAA, so we won't even have the data and we won't have the scientists, we won't have the infrastructure to study these problems. Any federal grants studying climate change, gone, defunded, completely, just totally defunded.
Oh,
so that's what we're dealing with now. In the meantime, it's, the effects of climate change are more urgent than we thought. But, I think, part of me has to believe, though, that the current crop of people doing this know that, the worst of it won't hit until they're dead, so they don't care.
Oh, yeah. Sure. That's a huge part of it.
Yeah, just completely
If they even
selling out the
believe it in
future.
any way.
Yeah, in many ways. In every way you can think of, they're totally selling out the future. All right. Evan, tell us about how quickly robots could learn to do physical tasks.
Yeah, there's been some news this week on that front. I'm going to call this piece How to Train Your Robot from Dragon. As in slowing down. Dragon. See how to train your dragon. And I smashed those two together. And
I got it.
You got it.
Phrase.
Thank you. Yeah. Let's role play a little bit, guys. All right. I want each of you to take the role of a robot designer. You've just designed.
Wait, are we a robot that designs, or are we somebody who designs robots?
You are a human that has designed a robot.
Okay.
You designed a human-sized robot with human-like features, arms, legs, hands, head. It looks human, and you designed it to take the place of humans doing manual labor. Okay?
Yep.
Okay.
So
now, you have to teach this robot to do a task. Any manual task you decide, sweeping a floor, picking up a box and moving it, basic kind of things that humans do. Give me a limiting factor in the teaching of the robot to do this task. What do you think some things limit our capabilities to teach the robot to do this task?
So not its ability to do the task.
Correct. Just about how are you going to train this robot?
I would train it in virtually. I wouldn't
expand on that, Bob.
They're doing a lot of that now, where the training is happening in a computer with you could have it training. Using say a physics engine, lots of people. You can have lots of people doing it, and then from there you could then translate that to a real world. So I think you could do it a lot faster virtually than just starting training it in meat space.
That's a great point. Any other thoughts, guys?
I think I agree with Bob. I was going to say that as well, because I know they're doing that, training it virtually, and then you have to train it on the actual task.
You have to train on the actual task, right, Steve? And when it comes to humans doing these tasks, we work on a very, human timescale.
Yeah.
Mm-hmm.
Yep.
Right? And therefore, a lot of the times when these robots are being trained, the human timescale becomes a limitation for that. Robot learning is slow because human tasks are, have nuance and context and physical complexity. And the current AI systems, they're doing okay right now, but they're still catching up to those kinds of demands. And one major challenge for robot makers is the lack of large-scale, real, and synthetic data to train these robots. Human demonstrations are not scalable. They're limited by number of hours in a day, for example. But robots also need to be tested in the physical world. So you have to compromise, but it's timely. There's a cost associated with that, and there are certainly risks, safety risks, also that come along with that.
Evan, can you train one robot or a limited number of robots to do the task, and then have those robots train the other robots 24/7?
Probably. You probably could if you can get to that point, right?
But you wouldn't have to have them.
Way of doing it.
I wouldn't think they'd have to specifically train other robots. They would just transfer the learning data over and bam, I know Kung Fu.
Yeah. So you train one robot, and then you just copy the programming to every other robot.
Right is eventually what you would do, but you still have to get that one robot up to speed and running, right? And in order to do that, you have to come up with better methods in order to train it, not on human timescales, but things that work better with robot learning and the way robots learn. And NVIDIA has come up with a way to make the learning time for robots as much as 60 times more efficient than they were for robots prior to this technology that just came out. NVIDIA has announced Isaac Groot N 1.5 which is the first update to NVIDIA's open, generalized, fully customizable foundation model for human reasoning and skills. So this is an upgrade to Groot N1. Under Groot N1, if a robot had to take, for example, 90 days to learn a task, whatever that task is, that robot can now do it in 36 hours. Can learn the task in 36 hours. You go from, it took 3 months for the robot to be able to process all this stuff and get it to the point where you need it to function correctly. Now it can learn the same thing in 36 hours.
However,
that's quite a jump.
However, when you ask it a question, all it says is, I am Groot.
I love that they used Groot.
Oh, yeah,
I love that they used it and didn't call it some, L2Z65 whatever. Like, astronomers, take note of that, please, when you're naming things. Thank you. Yeah, Groot N 1.5. It can better adapt to new environments and workspace configurations, as well as recognize objects through user instructions. And this upgrade significantly improves the model's success rate for common material handling and manufacturing tasks like sorting or putting away objects. And this is open sourced. It's out there. You grab it. And they have grabbed it. Since the announcement came out, I think it was Monday of this week, which is, we're recording this in late May. On the first day, I think 6,000 downloads of Groot N.15 took place. It learns quickly in large part due to a technique they refer to as dreaming. I don't know if you guys, have we talked about the dreaming way of learning for robots?
Dreaming.
Dreaming, that's the term. Here we go. Android's dreaming of robotic sheep moment. We've finally reached it. Oh, that's a Blade Runner reference, by the way. Kara?
Oh, thanks.
Just so you know.
Not just for me, just for all of you in the audience. Also, did you know that?
Well, yes, and for everyone.
I am the proxy for a particular type of listener.
So dreaming. In this context, dreaming means using synthetic data generation, creating large-scale, high-quality simulation data in virtual environments rather than collecting real-world physical data, right? So instead of using actual-time, real-world physical means to teach something, you do it, like Bob, you suggested, in a virtual environment. But essentially, it's dreaming for these robots, but they retain what they learn. What a wonderful advantage.
Why not?
Robots. Could you imagine if people could?
You could do that. You could practice in your mind.
But to the point where you can accomplish a specific task?
Well, I mean, there are limits because it won't really help your muscle memory as much, but just because of the way we are neurologically. But, you absolutely, like if you can train a sequence or think about things like that, you could do things in your head. I think people with aphantasia probably have a harder time doing that, but...
what about lucid dreaming, Steve? I think that would also go at least part of the way towards muscle memory as well.
I don't know about how that works neurologically.
While they are dreaming, they are practicing their tasks millions of times over in parallel across simulated environments. Millions of times.
Wow.
That's why this is reduced so drastically. The simulation data acts as a stand-in for actual sensor data, which enables the model to generalize skills before even being deployed in the real world. So this reduces the need for expensive real-world robot trials. It enables rapid iteration and scaling across many different tasks. And it allows the robots to safely explore edge cases, falling, colliding, failing, without all the real-world risks that are involved with such things. So this is much more efficient and safer, and certainly more cost-effective ultimately as well.
So when do the robots take over the world again?
So it was going to be in about a year or two, but now it's 60 times that. So next week.
All right. That's good. Bob, tell us about the most powerful solar storm ever recorded or known or whatever. What's going on?
By people.
Yeah, fascinating story here. Scientists have found evidence of the worst solar storm to hit the Earth ever found using a new climate chemistry model. With that, they were able to decipher the clues left over 14,000 years ago, farther back in time than any other previous model could accurately perform. This is from Science Direct. The title of the study is New Model Reveals that the late glacial radiocarbon spike of 2350 BC was caused by the record-strong extreme solar storm. To appreciate this news item, as usual, a little homework we got to go over here. You need some familiarity with carbon-14 and the link that it has with solar storms. Carbon-14, we've talked about it on the show a few times. It's a radioactive isotope of carbon. It's weak. It's really nothing that you need to worry about radioactively, like beta radiation. What happens, though, it's in its formation, cosmic rays hit the atmospheric nitrogen, and that turns it into carbon-14. Carbon-14 then combines with oxygen and creating radioactive carbon dioxide. And then from there, the radioactive carbon dioxide gets taken up by plants using photosynthesis, and animals consume the plants. So there, we've got carbon-14 in our bodies that's replenished every time we eat. So now this is the basis for radiocarbon dating, because carbon-14 decreases after death, right? So you're not eating it anymore, and then the half-life kind of becomes noticeable because it'll decrease. And so if there's less C14, then it's older. And that maxes out for what, like 60,000 years? Essentially, at that point, there's so little carbon-14 left that we can't even detect it. So then we have to use other methods for dating. All right.
Homeopathy,
yeah. Oh, yeah. Now, the link to solar storms, though, is that the storms create spikes of carbon-14 in the environment, like trees, for example. Just this pulse of carbon-14 that's created with all the particles that are part of the solar storm itself. An extreme storm, like we're talking about here, leaves distinctive spikes in, for example, in this example, tree rings. We could detect it, and it's like a fingerprint, but it's more complicated than that, of course, as usual. So there are some past famous storms, solar storms, that we're all aware of. But we've heard of all of these. But even before. Well, let's start with last year. They actually named last year's solar storm the Gannon storm of 2024. It actually saw a mass migration of satellites, because thousands of them began firing their thrusters to make up for the altitude loss, right? Because all those particles within the atmosphere essentially makes it denser. There's more drag. They lose their orbit, and they got to get back up to their maximal, their working orbit. So a mass migration of satellites. Interesting words there. Then there was the Halloween storm of 2003. Now that was similar in strength to the Gannon storm. For that one, it's similar to Gannon. Just like satellite trajectories were just changing predictably because of this denser atmosphere caused by all these charged particles from the sun. And then my favorite, the 1859 Carrington event, 10 times stronger than what we experienced last year in the Halloween storm. Order of magnitude stronger, took down telegraph wires all over the world. Luckily, technologically, we're basically the infancy of such things that could be impacted. And so it wasn't this unmitigated disaster that it would be today. Now, the strongest, though, I wasn't aware of this, the strongest of all the storms we had detected until previously was 775 AD solar storm. Doesn't really have a name. This was back when Charles the Great reigned in medieval Europe. There's few written records of this, but historians have found hints of this happening from ancient Chinese and Anglo-Saxon chronicles. So there are hints of it. So that's the biggest one that we have ever detected evidence for. But the thing is, though, we live in the Holocene, right? This is like essentially the from modern day till 12,000 years ago is considered the Holocene. It's interglacial, right? We're in a period of time between glaciers. It's characterized by relative warmth and stable weather, right? So that's kind of what the Holocene's all about. But we've never been able to detect anything outside of the Holocene because the weather was different, like the Pleistocene, right? It's very problematic. It was less warm. It was more glacial. And all of our models are meant really for a Holocene atmosphere. And so they don't really work reliably in atmospheres different enough to have their own designation, like Pleistocene. Technically, scientists would describe it as that we have a lack of carbon transport models that happened during those glacial conditions characterized, that happened in the Pleistocene. And we found tree rings from 14,000 years ago that were very notable. There seemed to have been potentially a huge spike of carbon-14, but none of our models could really handle it. They couldn't really decipher it. I mean, potentially it could have been a huge solar storm, but maybe it was something geomagnetic, or maybe it was due to climate change. So they couldn't really say with any scientific certainty what these spikes were in those the spikes of carbon-14 in those tree rings from 14,000 years ago. And so this is where the new model comes in. This is a new chemistry climate model called so-called 14C EX model. So this is where this model comes in. I mean, I won't go into too many details about it, but obviously this model is optimized for interpreting carbon-14 spikes during glacial periods, during the type of atmosphere that we believe was around when 14,000 years ago during this time. And what I liked is that they took this new model and they tested it against the 775 AD solar storm, which was clearly within the Holocene with modern atmosphere. And that solar event, 775 AD, the biggest one we've ever studied, obviously it's very, very well studied. They used this model against that, and the results were actually very favorable. The sense I get is that this model could be used in the Holocene and the Pleistocene. So it's kind of it seems like they expanded its capabilities to also incorporate the Pleistocene as well as the Holocene, because otherwise they wouldn't have tested it against the 775 AD solar storm. Okay, so what the conclusion is obvious. It's the largest solar storm. They believe odds are really good that this is the largest solar storm that's ever been detected. The most carbon-14 ever injected into the environment that quickly. Lead study author Kensia Golubenko said, "This event establishes a new worst-case scenario. Understanding its scale is critical for evaluating the risks posed by future solar storms for modern infrastructure like satellites, power grids, and communication systems." So yeah, this is important information for us to take and prepare for. So my big question at this point was, all right, that's interesting, but what would happen if this storm hit today? And it was hard to get some real solid predictions, but the obvious answer is that it would be a global crisis. It would be a disaster. There would be long-term blackouts. It would overload transformers, lasting weeks or months, or I think it could easily last potentially for years, because a lot of these things are not easy to replace, very expensive. Infrastructure damage, like I was saying, transformers, substations, high voltage transmission lines would be damaged or destroyed. We would experience huge problems with our satellites and a loss, I think, of a good chunk of some of our very important satellites. Because the high energy particles in the radiation can permanently damage or disable them. Imagine, having a GPS communications, weather monitoring being disabled or destroyed for significant periods of time. It's like, wow, not fun. There will be a disruption of air travel, which, it sounds kind of trivial with all this other stuff going on. But I mean, imagine having a lot of the flights that were happening to be rerouted or grounded. So essentially global travel chaos is what would result. And then don't even get me started on the financial markets, global financial markets, massively unstable. It would be, can you imagine? I just can't imagine a better, a worse day for the financial markets when that really hit. I'm not even going to say if, because this happened 14,000 years ago, and it's going to happen again. Just a matter of when at this point. And then finally here, supply chain collapse. And that's all about, global logistics, shipping and transportation systems. We could have amazing shortages for critical supplies, medicines, food. I mean, all right, have I painted the picture? There is a bright side. The bright side is the auroras would be off the hook. We would see auroras potentially in equatorial regions. And if you see auroras and you're at the equator, some shit is going down. And can you even imagine being in a polar region when this was happening? How amazingly bright that is. I would love to see that simulated. So yes, clearly this would be a global crisis. And I'm really hoping that this is a wake-up call, yet another wake-up of the many wake-up calls we need. I hope this is a wake-up call. But I'm not confident at all, because we are not very good for long-term possibilities or scenarios like this where, it could happen tomorrow, it could happen in 100 years. But if you look at the statistics, Steve, I never forgot that talk we did years ago about the probability of getting hit with even a Carrington level event, which is weaker than any of these. And the odds were not encouraging at all. I mean, I forget the exact numbers, but, within 20 or 30 years, it's just like
on average, it should happen within 20 years. Remember, actually, as pessimistic as you are, we have been hardening the grid for the last 10 15, 20 years. The bottom line is what I found is that we do not know what would happen. We just don't straight up don't know. And now we may know even less because we have like these new upgrades. But the thing is, like this one from 14,000 years ago, something that strong, that is hard, really hard to protect against.
Yeah.
Something that powerful.
It is. I mean, I think we should be making lots of transformers, just like, and I know they're really expensive. Make a bunch of them, store them.
Like we have a strategic reserve. Reserve. We have a strategic reserve of oil. We need a strategic reserve of transformers.
Right. Exactly. You got to harden these facilities. And yes, you're right. They have made progress. They absolutely have made progress. But I'm not confident that it's anywhere near enough.
Yeah. Well, enough again is relative. That's enough for how bad of a CME
I think
about.
Preparing for a Carrington level is reasonable. You don't necessarily because as we know, that last 5% protection could make it 1,000 times more expensive. But a Carrington level is reasonable.
Mm-hmm.
I mean, it only happened in like last 1800s, not that long ago. And like
with floods, they talk about flooding. They talk about a 50-year event, a 100-year event, a 500-year event, a 1,000-year event. Same thing with these coronal mass ejections. We have to talk about a 100-year event, a 500-year event, a 1,000-year event, and we should be protecting at least for the every 100-year event, if not the every 1,000 or 10,000 year event.
And hopefully, models like this will help us detect even more of these ancient solar storms, and we can get a better sense on when we might expect the next one.
And this is it's not just like an inconvenience, like you were saying, Bob. Like we could be out of power for so long that it becomes Lord of the Flies. Right. You know what I mean?
Oh my God, yeah.
Millions of people, tens of millions of people could die, as a result. It could take years for us to really get civilization back on track if it's bad enough.
Oh yeah, this would be...
Bob, interestingly, you used the term "off the hook" to describe...
I know. I was like, Steve, how excited that he said that
how cool the Aurora Borealis would be. Well, we're going to get to that in a minute. First, we're going to talk... We have two emails. That's actually the second email. The first email comes from Levente Vizi from Orono, Maine, and he writes a paper in Nature Energy written by Siobhan Powell suggests that we should be charging during the day to reduce strain on the grid. The idea seems very counterintuitive when thinking about lowering the peaks in grid demand, but makes sense for maximizing renewable energy usage. The other things I was wondering, which the paper doesn't mention, is how much excess energy production we would need on a day that has low solar and wind output. On such days, the demand on the grid would be very strenuous. An interesting idea, though. So he is talking about using car batteries for grid storage, but also the demand on the grid of recharging all of our EVs. The study he's referencing comes from September 2022, so it's a couple years old. But it's still relevant. And what they found was if you use a model of rapid electric vehicle adoption, right, so towards the more rapid end of the spectrum, by 2035, that's 10 years away, basically everybody recharging their cars overnight would actually increase the demand on the peak energy need of the grid by 25%. And during a stressful situation, could be up to 50%. It may not be, therefore, a good idea to have everybody recharging their vehicle overnight, and that it's better just to you're better off just saying, all right, just recharge whenever you want, because some people will be recharging during the day in terms of lowering peak demand on energy production. Does that make sense? But actually, when you look, you read this paper, and there are other related papers, because there was also like a paper published also in 2022 that said that with even conservative adoptions of EVs by, say, 2050, there could be between 32 and 62 terawatt hours of grid storage in EVs, in personal EVs. And that even with modest adoption by 2030, there could be enough EVs for that to provide short-term grid storage. Now, short-term grid storage means 2 to 4 hours, which doesn't sound like a lot, but that's enough to shift peak solar production to peak demand, as opposed to like days or months, right? Or seasonally shifting it. Like seasonally shifting it, we need closed loop hydro or something like that. but batteries would be used basically for short-term storage. But that's enough to balance the production and demand during the day, right? Throughout on the level of a day. But what all this means is that the expanding EV market is both an opportunity and a challenge. It's an opportunity because it could provide a lot of grid storage, but it's a challenge because it's also going to increase our energy demand. And it's going to, and again, especially if we're all charging our batteries roughly at the same time. Now, I think the same solution exists to both of these issues, and that is having all of the EVs networked, which they are, especially like if you have a Tesla, can't communicate to your car, but also like run off of software that is basically you just set it and forget it, right? We tell our Tesla, have the car ready to drive at 8 o'clock in the morning. And then it's always plugged in when it's parked in our garage. And then the car decides when to charge it, right? We're not deciding when to charge it. And it's based on a couple of things. It's based mainly on like when the lowest demand is, which is also when the electricity is the cheapest. But it could easily be, all right, like these computers just going to decide like when do we need to take energy from the batteries, like for peak shaving, when do we need to store energy into the battery, and how do we balance that demand across a vast network of millions of EVs to basically stabilize the grid, stabilize production to demand, and minimize peak demand. Right, so I think this is kind of an issue that's going to solve itself. Because, right, again, all we have to do is just keep doing what we're doing. You plug it in when you get home, and you let your computer decide how to recharge it. Yeah. And it's just a matter of incorporating that into the grid. Right now, there's a legislation in Connecticut that if you allow the state utilities, right, if you allow the utilities to use your home battery backup for grid storage, get me one of those. You get like a massive rebate on your battery, like $7,000, $10,000, like something significant. So that's good, right? That's it. Yeah, let us use your battery for grid storage, and we'll give you a huge rebate on the cost of installing battery backup in your home. So it could be the same thing, like you get a tax rebate or something. You get some kind of benefit for plugging your car in and allowing it to be used as part of grid storage and stabilizing the grid. I think we have to do that. Like this is going to have to be how things evolve, right? But at the end of the day, there's a lot of storage. There's a lot of energy storage in an EV battery. And there's no reason why we should have millions of batteries just sitting there and not be using it for grid stability. But I do think I'm confident that this is an issue that we'll take care of because this is all software at this point, right? Yeah. But let's get to off the hook. This email comes from Annie from Ontario. And Annie writes, I keep hearing Steve and his brothers use off the hook to mean a superlative. On the most recent episode, Steve said that the animation was off the hook on a show that he mentioned right at the end. I have always used the phrase off the hook to mean being let off without punishment, probably derived from a fishing metaphor, as in somebody did something bad and was let off the hook. I hadn't noticed the rogues doing this until the last couple of years. I've been meaning to write in about this for some time, but keep forgetting, and I'm usually out and about when I'm listening. I happened to be at my computer when I heard this time. Is this more of a New England thing, or is it more widespread? In my life, I have never heard anyone use off the hook to mean great or excellent. Any idea when this started to become more commonly used? It drives me crazy every time Steve or one of the others says it. I've never noticed Kara or Evan say it. I don't know if you guys do.
I think it's only Bob that says it.
I don't know why I gravitated towards that expression.
Do you say it,
I absolutely have said it, yeah.
Oh, I feel like you guys are mixing up off the hook with off the chain.
So we're not mixing up anything.
I think it became more commonly used around May of 2005.
No, but I guess it's true. Some people do say, like, that's off the hook. Like, that party was off the hook.
Yeah, exactly.
Linguistic pioneers.
But I definitely hear off the chain.
We're not pioneers. So this is the history of this. So the term off the hook goes back to the mid-1800s, and it was a fishing metaphor, and it did initially mean like to be let off of your responsibility, right?
But to be fair, it didn't just initially mean that. It still means that.
Yes, it still means that, yeah. I'm saying,
people use
I don't
that
mean initially as if it doesn't mean that
one
anymore.
of its meanings.
That was its first meaning. like the term off the hook. However, some references say that it may also have been used to refer to like leaving your phone off the hook. Right?
Oh, I'm seeing that in etymology. Yeah, I just looked up the etymology. That's the second etymology.
That's the second
Phones
word.
used to have hooks.
Phone. Yeah. You would leave it off the hook to prevent yourself from getting phone calls. Yeah.
Or you could say, my phone is ringing off the hook. Have you ever heard that?
That I've heard. Yes, that's the one.
God.
Which means like it's out of control.
Right.
Like it's ringing.
Like physically moving, it's ringing so much.
So that's what we've appropriated.
No.
Off
It
the
means
hook.
that you're getting called so frequently that it's ringing off the hook. That's what that means.
Yeah.
But in the 1980s and 1990s, it took on a different meaning in Black urban American hip hop culture.
Yeah, AAVE.
Yeah, exactly.
Yeah.
And this usage was to mean impressive or superlative, right? Like this party was off the hook. And that then got mainstreamed by the early 2000s. So we're just picking this up from the mainstreaming of this, Black urban culture slang of using it to mean awesome. But that's 20 years ago, 30 years ago. It's not new. We didn't make it up. It's not New England. It's just this is a mainstreaming of, they're saying, mainly hip-hop culture.
But also off the chain, by the way. They sort of cross.
Yes, but off the
hook and
chain is like your dog is off the chain. They're wild. It's loose. It's crazy.
But it means this. But they're both like superlatives. Yeah, they mean like cool.
Yeah. So I don't know. And that's one of the speculation is that it kind of merged off the hook and off the chain. But there's no evidence of that, and it could have just been that somebody just started using it to mean this is awesome. It kind of sounds that way. Like when you say like this is off the hook. It kind of sounds that way,
Yeah.
It sounds like this is amazing,
It is a funny, it is a bit jarring, though. And I can see what she means because it's like one of the only types of those sort of phrases that you guys use. Like this very 80s, 90s.
Well, we have
urban.
We have proximity to New York, and that's probably the path that it took to our vernacular.
Yeah.
And I like it. Get used to it.
Yeah.
People.
I like it too. I like saying it.
It's just
off the
something,
hook,
something
man.
rewarding about it.
It's totally rad.
That's so. It's so weird because why would I have never noticed you say it, Steve? But I always notice. I think maybe Bob.
You might use it more, but I definitely use it.
I use it.
I even know what they're talking about. I know the episode they're referring to. I definitely.
Funny. Jay, what about you?
This whole thing absolutely came from, I think, rap music influence, listening to MTV and things like that. I mean, we didn't make it up. It was absolutely something that we picked up from the culture, and it was not a mild infusion. It was everywhere. Everybody was saying that in the 80s.
Mm-hmm. Really?
I guess I'm
I
more
don't
meant,
say
do
that
you say it
anymore.
often
No.
now? Because I didn't think so. Yeah, I don't think I've ever heard you say it. So it's mostly Bob and also
Occasionally
Steve.
Steve.
Fair.
Okay. And never
Evan, have
Jay,
you used it?
Evan
Nope,
or Kara.
I do not use it.
I don't either.
Bob and I are just cooler than
And if
the
I
rest
was
of
going
you,
to say
apparently.
something was off the
That's
hook,
clear. That's clear.
the sentence would start with, that shit was off the hook. It would never be like, hey, that was off the hook. It'd be like, that shit was off the hook. You know what I mean?
Yeah.
And I would definitely always use it the way that our dear writer, like, okay, guys, you're off the hook. We
I
don't
use
have
it
to
that way
record this
too.
week.
I also
Yeah.
use it that way
Yeah.
as well.
I just haven't.
What about off the hizzy? That's a variant of off the hook.
Never heard it.
We're just
Never.
gonna stop there.
I first
We're just
heard that today.
Wow.
Right now.
No, that definitely.
That's even too cool for me. Off the hizzy.
No, this should, yeah,
I
this
say
is
it's for
far
shizzle.
too
Is
late.
that okay? Can I say
That's
that?
like saying
Just-
for
we're just gonna-
shizzle. It is. That's off the hizzy.
Yeah, I say that all the time.
We have one friend who non-ironically uses the term shizzle. But anyway,
Oh no.
True.
maybe not anymore. It's been a while, but we'll see.
Oh boy.
All right, guys, let's go on with science or
That
fiction.
letter
Please.
was off the hook.
It's time for science or fiction.
Each week I come up with 3 science news items or facts, 2 real and 1 fake. Then I challenge my panel of skeptics to tell me which one is the fake. We have a theme this week. The theme is loosely based on Nauticon. The theme is not a pig.
I have never been to that conference.
Not a pig.
So wait, these are things that are not
These are things that are
pigs?
not pigs.
Okay.
I like it. That narrows it down.
It'll make slightly more sense when I start to give you them. Okay, item number 1. I think this is pronounced Scotoplanus, Planes, planus, Scotoplanus.
What'd you call them?
Also known as the sea pig, is a round pink sea cucumber that uses elongated feet as legs to walk on the soft ocean bottom in the deep abyssal plain.
Abyssal, my nizzle.
Number 2, my shizzle.
In the deep shizzle plain.
The deep.
It's so painful.
All right. Number 2, not to be confused with the hognose snake, the large anaconda pig snake is a roundish and mostly pink South American snake that is trapped for its abundant and apparently tasty meat. And item number 3, the river pig is a finless freshwater porpoise that is round and pink in color with intelligence considered comparable to that of a gorilla. Right, so these are 3 animals referred to as pigs, at least in their common names, that are not pigs. All right. Kara, go first.
Okay, so we've got a sea pig, which is a little sea cucumber. We've got a pig snake, a large anaconda pig snake, and then we've got a river pig, which is a porpoise. Okay, so river. I've never heard of a freshwater porpoise being called a river pig, but I do know that there are pink dolphins in the Amazon River, or in the Amazon region, and so these pink dolphins could be called river pigs. Why not? They're pink and they are freshwater, so that seems reasonable. And intelligence comparable to a gorilla? Sure. I mean, cetaceans are really, really smart. We know this. Sea pig, I feel like when I think about like aplysia or sea cucumber or like all the little kind of, what are the ones I'm thinking of that are really colorful but all of these little animals that you might see when you go like tide pooling and stuff, there are so many of them and they're so vibrant and they have such really interesting and unique looks to them that I could see that one being reasonable. The one that bothers me is the large anaconda pig snake. A pink anaconda. I think I would have seen this before. And also, anacondas are big. They're charismatic. They're just these large creatures. I feel like I would have heard of this. So that one's bothering me. I'm just going to say that's the fiction.
Okay, Bob.
Yeah, I mean, nothing really jumped out at me that much except for this anaconda. Fusing the idea of anything pig-like with an anaconda just was rubbing me the wrong way. Otherwise, but I'm just rolling the dice here. Oh, I should get my science fiction coin out. Oh, damn. I don't have my damn coin. It's upstairs.
We can just
but I'm going to go with the anaconda. and Kara say that's fiction.
Okay, Jay.
The Scotoplanes, it just sounds like a name you made up, Steve. The deep abysmal plain. That's pretty cool. All right, yeah. I mean, this is all spitballing. Let me see. The hognose snake. It's an anaconda pig snake, but it's not a pig. The large anaconda pig snake. That sounds fake too. The last one, the river pig, is a finless freshwater porpoise, right? Oh, sorry, I'm reading that off the internet.
Porpoise.
I'm just kidding.
You did that on
It's
purpose.
considered comparable to that of a gorilla. A gorilla, a pink water porpoise gorilla. That's crazy. The river pig. How come we haven't heard of any of these guys? Let me see here. There's a coin. Okay, I'm gonna say the second one is the fake. The pig, the hognose snake. No, I'm sorry. That's the other name for it. The anaconda pig is not real.
Okay, and Evan.
Jay, did the coin tell you to say that?
No, I just you did a series of moves with it that led me to the truth.
So it's a divine coin.
It's the divine coin.
Steve, I'm surprised you didn't go with whistle pig.
I know you guys know the whistle.
The pink is throughout all these answers. Everything's pink.
Yeah, they're brown and pink. That's why they're all called pigs.
Is that why? Yeah, I was thinking. Okay, what should I do, guys? Should I go against everyone and say the river pig one with the intelligence comparable to a gorilla? That one? That didn't surprise anyone. Kara, you seem to think that was perfectly fine.
Well, cetacean.
Not saying
Don't
anything.
say anything.
I'm allowed to ask probing questions or get comments.
Sure, ask
Not
any
allowed
questions
to
you
not-
want.
You get no answers or feedback. That one is really the one I want to call the fiction. But everybody else went with the anaconda pig. So there's this pig pressure of me to go with the anaconda pig as the one being the fiction. But I don't know that you have great reason to assume that. Therefore, I will boldly go where no pig has gone before and say the river pig, that one, is going to be the fiction.
Okay. So you all agree with the first one. So we'll start there. Scotoplanis, or planus, also known as the sea pig, is a round pink sea cucumber that uses elongated feet as legs to walk on the soft ocean bottom in the deep abyssal, not abysmal, plain.
Same thing.
You guys all think this one is science, and this one is science. This one is science. Has anyone seen this critter before? I know of it before. Pretty cool looking.
It is weird, though. It totally looks like AI made it.
Oh, so
I am now.
I'm not.
Well, now, yeah.
It's got like a bunch of legs on the bottom. It's got these 4 tentacles on top. The legs are operated by like filling it, with fluid. They're just feet that are like elongated into legs. And they often have crabs, like these little king crabs, but they're not parasites. They just sort of hitch a ride for safety. These things, eat a lot of stuff. They're basically, they eat all the crap on the bottom of the floor, right?
I see.
So they're sea dogs.
They'll even eat whale corpses. They tend to exist in collections of like 300 to 600 individuals. So yeah, they are very cool looking.
Oh, I was thinking nudibranch. That's the word I was looking for that I couldn't find.
Okay, well, what's that referring to?
Well, a little nudibranch. They're like they're sea slugs, and they come in all different colors and flavors, and they're really
he created
cute.
Slugs. Any movie?
They're also very deep, so if you do bring them to the surface, they do tend to shrivel and die.
That's sad.
All right, let's go to number 3. The river pig is a finless freshwater porpoise that is round and pink in color, with intelligence considered comparable to that of a gorilla. So how do we compare the intelligence of different animals? That's the question. One way
Make them look in the mirror.
is
Mirror test.
the mirror test, right? So do gorillas pass the mirror test?
Yes.
Does this finless freshwater porpoise exist? And if it does it pass the mirror test?
I don't remember
Probably
hearing
not.
about porpoises passing that test.
Well,
I think so, yeah, but
think
I
so.
don't specifically remember.
My guess would be that they 100% do. They're super smart.
this one is science. Sorry, Evan. But
Yay.
the gorilla does not pass the mirror test, and neither does this porpoise.
Are you serious? Really? How the hell?
But do they pass a version of it that was made for them?
So from what I'm reading, because I checked it out, so first of all, they're saying like every reference I read is like they're considered to be as intelligent as gorillas. Like, okay, but then my first question was,
does that mean?
Gorillas pass the mirror test? And the answer apparently is no. Chimpanzees do, but apparently gorillas don't. But
Which makes no sense because gorillas can communicate with sign language, but they can't see a red dot on their face and know it's them. I'm like, maybe. But again, we know that the mirror test is actually quite biased because it's like geared towards animals that have a lot of specific skills. It's not the
only measure of intelligence or sentience or whatever.
Self, or even just self-concept or recognition.
But in any case, they said, according to studies, they're as intelligent as a gorilla. Okay, whatever. But yeah, they're cool looking. They're finless. They have no dorsal fin, right? So they have a smooth head. They do have a dorsal ridge, but they have no dorsal fin. They are freshwater. They're not in South America, though. They're in the Yangtze River in China. And they are critically endangered, less than 2,000 individuals. But yeah, they're not pink at every age. They usually start out gray or dark gray, and then they lighten up as they get older, and some of them get just like pink color. The pig, you could find pictures of them that look like swimming pigs, in terms of like their skin color. But so they exist. Which means that, not to be confused with the hognose snake, the large anaconda pig snake is a roundish and mostly pink South American snake that is trapped for its abundant red and apparently tasty meat, is the fiction.
Oh boy.
Now, the hognose snake is real. That looks like a rattlesnake with a hognose, like a turned-up nose. The large anaconda pig snake, I just completely made up. It doesn't exist.
Of course you did.
But I imagine if they did exist, they would be quite tasty. Have any of you guys eaten snake?
Never.
Yeah, I've had snakes.
Nope.
Does it taste like chicken? No. What does it taste like?
I don't think so. I think a lot of things that people say taste like chicken don't taste like chicken. Like frogs don't taste like chicken.
Nah.
I think it tastes more like frog than like chicken.
What does it taste like? Is it greasy? Is it gamey? What would you say?
It's muscular. So to me, it was like gamey.
Oh, thanks.
But gamey is such a vague, like gamey is just anything that's like
It's got a weird taste.
I guess.
Gamey,
Yeah. But definitely gamey. There's a lot of like if you're in Florida, if you're out here, even in California, there's a sausage place sort of near me that specializes in like quote exotic sausages, so you can get like rattlesnake sausages.
Yeah, I've had that. I've had
It's
like
not that
whatever
hard to find
snake
rattlesnake.
bits or bites
Yeah.
or chunks or whatever before.
Snake
It
bites.
tastes like alligator to me. It was similar to that.
Yeah, totally. Like it's a little bit. I guess greasy is not quite the right word, but definitely more
Yeah.
gamey than like.
It also depends on how you prepare it. I'm sure, like if you know what
Totally.
you're doing, you can make anything taste good. Yeah.
Oh hell yeah!
Yeah, I had haggis. It was
Well, just
great.
cultural norms.
Once
yeah.
Yeah, it's
against all expectations.
Yeah, that was
You know.
surprising. I think
Oh,
there was a
haggis
lot of
does taste really
non-haggis
good.
You
like
did not
things
have
in
right
there.
15th century.
Yeah, it's a big
haggis.
difference. I know.
But that's my point. If you cook it properly, or not, properly. If you cook it in a way that's accessible to an American like me, yeah, it could taste good.
And that's really the point, right? Because there are things we eat here that other people are
Like
like
hot
"I
dogs.
cannot
Hot dogs
believe
are
you
our
would
one
eat."
thing that the rest of the world
Yeah.
thinks is disgusting that we love.
Or bologna.
Yeah,
Bologna.
Oh god, bologna's like hot
yeah,
dogs. on
bologna's like the
steroids.
kid
Like,
version
it's like
of a hot dog. Like I liked bologna when I was a
Yeah.
kid. I would not eat bologna today, but I
haven't had
still
that in
love hot
decades.
dogs.
You have a degree in
Like
bologna.
a nice boiled hot dog, I love it.
a boil. Ew, I can only eat an all beef hot dog that is made on
Grilling
the
is even
grill.
better,
It's,
but
like,
even
slightly
boiling
Grilling's
is fine.
good.
I like boiled hot dogs.
I can't do it. That bologna, like boiled hot dog,
Boil
taste
'em,
is just
says
so
I.
porky. It's just so overtly porky. I can't do it.
But if they're grilled, you're good.
Also, maybe
Totally. And if they're
throw
all
like
beef.
I prefer the all beef.
chili on it or
I agree.
ketchup or whatever mustard.
I like mine
Yeah.
plain.
Plain.
Ooh, you know what I
Plain.
do, Steve?
Savage.
You might like this. I don't know. I don't know if this is a Texas thing or just my weirdness growing up and in Texas thing, but I put baked beans
Ooh.
on
No, I've seen that.
I like that idea.
probably
Chili,
do
that's
that.
like a chili dog.
Delicious.
Yeah, I like that idea.
It's like a chili dog, but they're
Yeah.
baked beans.
I could do
Oh,
that.
yeah.
I don't like mustard or ketchup, though.
Perfect.
I don't like condiments.
Me neither. I don't like mustard or ketchup, so otherwise I would eat them plain or with cheese. But with baked beans, it
Yeah,
gives
I
them
like
the
it.
best.
I
I
like
got to
it.
try that.
pork and beans.
Pork and beans, yeah, exactly. Or beef and beans.
All right, good job, guys. You didn't go for my anaconda pig snake, huh?
No.
I did.
Evan did, yeah.
It was delicious.
All right, Evan, give us a quote.
Of all forms of deception, self-deception is the most deadly, and of all deceived persons, the self-deceived are the least likely to discover the fraud. So that was said or written by a gentleman named Aidan Wilson Tozer, Tozer, who, and I like the quote. Do you like the quote?
Sure. We've had that in many versions. You know, there's different ways of saying
Many
that.
guises.
Now, here's the thing about Tozer, though. He was an American Christian pastor from the early 20th century. Very much a pro-Christian person, an evangelical, and did all these things. So, in regards to that, however, he has some quotes for him and some things that he's written about that have these tinges of skepticism to them. It's like he almost got there, but didn't really fully apply it to everything in his life.
That is very common. I'm hearing that all the time, even today, from people across the political spectrum, pseudoscientists, science deniers. They talk the talk, but they don't walk the walk, right? They say they enunciate perfectly cromulent skeptical principles, but clearly they're not applying it to themselves
Exactly. Not
Right.
self-applying. Right. They can't look in the mirror.
or to their sacred cow, whatever that
Yeah.
is. Yeah.
And in this case, for Tozer, that's the exact correct term.
Yeah, just religious belief is the ultimate sacred
Tozer?
cow, right?
But if you were to read some of his writings and passages, you would say, "Oh wow, these are good little skeptical nuggets,"
Yeah.
which they are on their own. They're just not applied correctly when it comes to certain beliefs and things.
The best manifestation of that was the flat earthers. Like if you watch the movie Behind the Curve, where like one flat earther is describing the conspiracy thinking and science denial of another flat earther that they were fighting, like they were disagreeing with, and then they go, "Is it possible I'm doing that?" Then they had that Theodoric of York moment. Nah.
Oh, you're so close.
So
you
close.
almost had it.
I know.
Let me take my hand. I'll help you. I'll pull you.
They walked right up to the abyss, but just couldn't jump in. They just could not do it. Oh well.
Oh, well.
Yeah.
Or the abyssal plane.
Yeah, or the
They walked
abyssal,
up
the
to.
abysmal plane.
Yep.
Yeah, that's off the hook, man.
Yeah, it's off
Here we
the
go. Here we
freaking
go.
hook. Well, thank you all for joining me this week.
Sure, man.
Yes, Dave.
Thanks, Steve. Have a good July.
Thank you.
And until next week, this is your Skeptic's Guide to the Universe. Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.